Okay, so arsenic. What's the noble gas that comes before it? Argon, okay. And then what do we put after that? 4s2, 3d10, 4p3. Does everybody agree? Yeah? Okay. All right, so that's electronic notation, or electron configuration. It's the shortcut method. The next thing we do here is the orbital diagram. So it's very similar. AR, 4s, up, down, 3d, 1, 2, 3, 4, 5. It's all filled. So they're all up and then all down. And then 4p3. 1, 2, 3, up, up, up. Okay, and I'm gonna draw an arrow so that I remember that that's the last one I drew, because when we do quantum numbers, that's the one we're gonna talk about, okay? Now, the dot diagram, that's what we were talking about before, where you would actually put AS for arsenic, and then you would put as many dots around it for valence electrons, okay? And this is where it could get tricky. Because if you look, what's the definition of a valence electron? Does anybody remember? Highest energy level. Yeah, exactly. Highest energy level. What's the highest energy level here? The 4, right? So that means you're not including the D's, right? You're only going to include 4p and 4s. Okay, so you want to make sure you include both of them. So that's 5. All right. And with the kind of the rule for this is you're going to put 4 around it. And then after you have 4, then you can start doubling up, okay? You're kind of pretending that there's an invisible, whoop, that didn't come out right. There's an invisible box around it, and you can put up to 2 dots on each of the sides. They like to spread out, all right? So you do those 4 first, and then you would double up. And it doesn't matter where you double it up. You could do any of the sides, okay? But that's what we would look for a dot diagram, all right? Okay, quantum numbers is the next thing. N. All right, what's our N for this? 4, yeah, exactly. So where do we get that from? Yeah, N is the energy level, so that's gonna be 4. What about the L? Yeah, it's gonna be 1 because L is the orbital, right? The P there, and it was S is 0, P is 1, and then it just goes there, so that's good, up from there. All right, what about the M sub L? That's 1 as well, right? Where'd you get that from? Yeah, the number line, right? So 0 is in the middle. That's going to be a 1. This is going to be -1. All right, so that's 1. Good. And then the last one is +1/2 because what? It's an up arrow. Yeah, exactly. It's an up arrow. Okay. Para or dia? Magnetic. Okay, yeah, it's going to be para because para means you need at least one that's like this, one that's by itself, all right? So that would be para. Dia, I'm sorry, because I said it out loud. Dia is when they're all up, down, okay? There's 2 in each of the orbitals, all right? So this would be para. All right, any questions with that top one? No? All right, let's jump to the bottom, or the back. This is the top of the back. This combines both the shortcut and the orbital diagram just to give you a little bit more space to write it out. So let's do that. Ra. What's the noble gas that comes before radium? Radon, yeah, I started to write it. Radon. And then what do we put after radon? We look, it's 7s2. Okay, so 7s2. And then we do the orbital diagram, which is the same thing, Rn, 7s2. Okay. Is it a transition metal? No. So what's its charge going to be? +2. It's not a transition metal, so that's the only possible charge for it. That's all we're going to come up with this year in honors chemistry. It's going to lose the valence electrons, right? It's going to lose +2. It's in that group. It's just going to follow those rules. So by doing that, it's just going to stay +2. Whoop, that's okay. And then now we need the reason. I know, it's falling apart. We can recover. What's the reason for this? When it loses 2, what does it then look like? Radon. So how do we say that? There was a word we used. Good. Oh man, I might not be able to write it. Iso-electronic to. All right. And remember, if you can do that one, that's the best for them. Okay. So on the back, you're not going to just have transition metals. You're going to have anything, and then you have to realize that if it is a transition metal, there may be more than one charge. All right, and you have to figure it out. But if it's not a transition metal, the old rules still apply. All right? Okay, any questions with that one? And we'll do more examples.